Hello! In this screencast, we'll be walking through a deployment of JupyterHub on Hadoop. JupyterHub is a way of deploying a multi-user Jupyter Notebook interactive compute environment. It supports many different backend infrastructures. Commonly it's run on Kubernetes. In this case, we'll be walking through a deployment on a Hadoop cluster. So right here, you can see I'm presented with a login page. I'm signing into JupyterHub. JupyterHub authentication is pluggable. Here we're just using a username and a password, but other options exist. You can log in with Kerberos, you can log in with various other authentication schemes. I'm going to log in as the user Alice. Right now, as this is logging me in, it is going to spin up a Jupyter Notebook environment. This is going to be running somewhere in a Yarn container on the Hadoop cluster. Every user gets their own Jupyter Notebook environment. This is running in a Hadoop in a container, which means that we get the nice resource restrictions and handling of other Hadoop applications. No single node is saturated. No node is using too many resources. If my Jupyter Notebook environment starts using more resources than the administrator has configured, it will shut down and the user will be notified that they were using too many resources and they need to rethink things. This helps make sure that all users have access to the cluster and no user overuses the cluster. All right, right here you can see we are dropped into a classic Jupyter notebook. I have a couple of notebooks right here that are already stored in JupyterHub. JupyterHub storage is pluggable. In this case, these notebooks are stored on HDFS. There are many different alternatives. This could also be stored in a database or in some object store like S3 or GCS. I'm going to also, besides having a notebook, we can also start other things. I'm going to start a console or a terminal. So as I said, I am logged in as the user Alice. This is running somewhere inside the Hadoop cluster. So I'm not running on an edge node, I'm running in a Yarn container. If I type who am I can see that I am logged in as Alice. And if I try to access HDFS, you can see that that actually works, which means that I have a delegation token. I'm fully logged into Hadoop. This JupyterHub on Hadoop deployment here fully integrates with Hadoop. Hadoop security, Kerberos, various other things are all handled transparently. If I also type my working directory, I can see this long string is the path to the working directory of this Yarn container, just to show that I am actually in a Yarn container. Let me close this out. And if I refresh the Hadoop web UI, we can see right here is my JupyterHub application. All right, going back, I am going to create a new notebook running Python 3. I'm going to name it demo. So, one nice thing about using JupyterHub for providing users with a standard compute environment is that administrators can pre-package environments with packages the user might want. This helps prevent development issues where different users might have install problems. All users have the same compute environment, which is managed by an administrator. There are ways you can configure this where a user can also provide their own with additional packages they might want. But commonly it's used where an administrator pre-packages the packages the user might care about. So here I'm going to import NumPy, can import pandas. These are all installed. These are all working. Create a quick data frame just to show that everything works. Cool. Let's close this out. Shut down that kernel. Besides the standard notebook interface, JupyterHub also has pluggable front ends. So it can have, besides notebooks, we can also work with JupyterLab, Interact, RStudio, and various other UIs. Here I'm going to swap over to using JupyterLab just to show that in action. So this is JupyterLab. JupyterLab is a more full-featured UI. Over on the left we have all the notebooks that you saw before. I can create new notebooks and consoles and terminals. It also has a large extension of plugins. Over here on the left, we see the little Dask logo. This is the Dask plugin. So as I said before, this notebook instance is running somewhere in the Hadoop cloud, or in my Hadoop cluster, with a limited set of resources set up by administrator. I believe I've configured this to have 2 gigabytes. For larger data, if I want to work with a large data set, often we want to plug into existing large data tools like Spark or Dask. I'm going to walk through 2 additional notebooks showing their usage and how they might integrate well with JupyterHub on Hadoop. Let's start with the Dask notebook. So I'm going to open that up. So here I'm going to create a Dask cluster. This is going to spin up an external application also running on the Hadoop cluster. And we should return pretty quick here. This is configured by an administrator. If you're an administrator, you can pre-configure Dask configuration so that your users don't have to pass any additional parameters to the constructor. They can just create a yarn cluster. All right, so we have a cluster. If you're familiar with Dask, you might know that it has a nice interactive dashboard. The dashboard is proxied through JupyterHub. This is fully authenticated. Only I, as the user Alice, have access to see what's going on. This is all handled through JupyterHub transparently. I'm going to copy that address and add it to the Dask plugin here. Cool, and that'll come in handy later. All right, I'm going to scale this up. So here I'm going to create 4 workers, scaling up. This is a nice interactive widget. While that's running, I'm going to open back up the Dask plugin, and I'm going to open the task stream and the progress profile. So as we can see here, JupyterHub has multiple different tabs, and these are draggable. I can actually drag this over here to the side. So now as a user, I can view my Dask dashboard while I'm actually computing. And I've scaled it to 4 workers. I'm going to read some data off of HDFS. This is stored as CSVs. We have a whole directory of CSVs. It's going to do some parsing. This all looks like normal pandas calls. And over here on the right, we can see the work actually happening. While that is going on, I'll open back up the web UI for Hadoop, and you can see over here, here's my Dask application. So this is also running in Yarn. We have multiple applications running on the Hadoop cluster at once. Here is my Dask work ticking away. I can peek at the data, peek some simple stats on it, various different things that analysts might actually want to do. And I can also make a plot. So here we're going to compute resampling of 2 different columns by days and take the mean, and then I can plot those by day. Getting a nice little interactive plot done here. Okay, I'm going to close this notebook out. So closing down the different things. And then opening back up here, I'm going to shut down that kernel. So besides Dask, JupyterHub on Hadoop can also work well with other large data tools like Spark. So here I'm going to open up a Spark notebook. Just as with Dask, with administrator configuration before, you can configure so that the user only needs to create a Spark context. They don't need to pass any additional parameters to it. This is spinning up a Spark application. And over here on my Hadoop web UI, I should see that spinning up. Here we can see that the Dask application finished successfully, and Spark is now running. Cool, I have a Spark context. I can create a SQL context, and I can read the same data in that I read in with Dask. So different users can use different large data tools dependent on their familiarity with them and what they want to use. Besides differences in tools, JupyterHub also works with many different languages. There are kernels that can work with both Python, which you're seeing now. You can also work with R, Julia, Scala. Really, there's I think 40 languages supported at this point. So pluggable front ends, pluggable languages. You can let your data scientists use the tools that they are familiar with and good at using. All right, so this is showing that Spark works. If I shut this notebook down, it's also going to clean up my Spark context, and the job will shut down as well. That also happened with Dask. Anyway, this has been walking through JupyterHub on Hadoop. There is much more information on the JupyterHub on Hadoop documentation page. This is a full walkthrough of how to do a deployment and also a customization, various things that you might want to use. I hope this has been useful for you. Thank you.